Hey folks, I have only two questions for you. One, are you trying to find a job in IT? And second, are you trying to gain some core knowledge of IT? If your answer is yes, then you have come to the right place. This is the course for you. Now, no matter which IT field you want to pick, maybe you want to become a Linux administrator, Windows, a VMware, networking, storage, security, programmer, developer, whichever field you pick, you have to know the basic, the core, the fundamentals of IT, such as what is a CPU, how it functions, what is a core, what is a socket, what is 32-bit or 64-bit architecture, what is OSI network layer, what are the difference between TCP/IP and OSI, what is an SQL, what is a RAID, what are the different type of storages that are out there. These are the basic things you have to know before you step into IT. My name is Imran Afzal, and I've been in IT since 2001. I've been working for Fortune 500 companies in New York City. I have bachelor's degree in computer information systems from Baruch College, which is the City University of New York. I also have an MBA degree from New York Institute of Technology. I have been teaching since 2010, and I have helped so many of my students land the dream job that they have been looking for years. So, are you ready to take this journey with me? Together, I could teach you everything you need to know about the fundamentals, the core about IT.
Hello, beautiful people. Let's spend a few minutes and go over our course syllabus and understand what exactly is included in this course. I have broken down this course in 15 different sections. In section one, we'll talk about the introduction to IT. That is the meaning, the importance, and we'll talk about computer language, zero and one. We all talk different languages in humans, but in computers, there are no languages like English or Chinese. We'll talk zero and one. Then every section will have quizzes and handouts. Moving on to section two, which is the computer components, we will slightly cover every single component of computer, such as hardware, software, operating systems, application, networking, database, storage, virtualization and cloud, security, quiz, handouts, and homework. Then starting with section 3, we are actually going to pick each one of these components and we're going to drill down. So starting with section 3, hardware, we'll talk about different type of computers. We'll install RAM and I will show you actually when I'll open up the computer, I'll show you where RAM is located and how you can replace it. Similarly, we'll do for CPU and its core and sockets. We'll install the CPU, then we'll talk about the 32 and 64-bit processing architecture, disks, hard disk, motherboard, other internal parts of computer, external components, hardware manufacturers, computer comparison with our human body, and then quiz handouts and homework. Moving on to section 4, which we'll talk about everything about the operating system, the types, the functions, the buildings, CLI, and GUI operating system, computer boot process, and then we'll end with quiz handouts. Then moving to section 5, which will be the software and different type of software, system software, application software, freeware and shareware, open source software, BIOS and accessing the BIOS, program and services. So everything that you talk about, there are so many things you probably heard about software. Hey, is this a free software? We'll talk everything in this section. Then moving on to section 6, which is about networking, how computers communicate with each other, IP address, TCP/IP, gateway, subnet, MAC address, OSI layer. I'm sure you have heard of it, but I will take some time and explain you how it works and how important it is in computer networking. We'll talk about OSI and TCP/IP protocols and ports, types of network devices, how internet works. Moving on to section 7, which will be everything about database, RDBMS, which is a relational database management systems. What is SQL? Top 5 RDBMS. Then section 8 comes the storage. computer storage introduction, how storage is calculated, types of storage, difference between RAM, swap, virtual memory, and cache, hard disk, SSD, solid state drive, RAID, top data storage vendors. Then moving to section 9, virtualization cloud, how virtualization works, basic virtualization terms, benefits, difference between cloud and virtualization, the technologies, VMware Workstation Player, Oracle VirtualBox installation, setting up virtual machines. We'll talk about how we could do the installation. We will actually do as a lab setup, and I will make you go through setting up these virtualization software and setting up virtual machine. Then coming down to security section 10, another most important component of IT. We'll talk about different threats, breach, how we could secure operating systems, physical server applications, and so on. Then section 11 is about Windows operating system. You are getting into IT, you should know somewhat of Windows. We're not going to cover everything about Windows, of course, but a very few important topics of Windows, such as file systems, system resources, server managers, role and feature, Active Directory, and so on. Same thing we'll do with Linux. We will install Linux together and we will access the Linux, how we could access file system, directory listing, system utility, and so on. And then the troubleshooting concept. So this is very important for anyone who is getting into IT in terms of how you could troubleshoot. In section 14, we'll talk about the introduction to AI and ChatGPT, which is everyone is talking about. We'll start with what is artificial intelligence, its history, the feature it has to offer. We'll get into AI versus robots, the benefits of AI, and the limitation of AI. Then the last section is about introduction to DevOps. A lot of IT people wants to get into DevOps, so I wanted to definitely cover this section. And in this section, we are going over what is DevOps, its history, what are the challenges of pre-DevOps, team collaborations, the benefits of DevOps, and the importance of DevOps. Now you decide yourself, does this course has so much to offer that you could learn so much about IT and then you could start anywhere you want to go in IT. Good luck to you. Hey, beautiful folks. Before we get into the details of IT, let's take a few moments and understand the true meaning and real meaning of IT. We all know IT stands for information technology, but what does it really mean? It's a transfer of information from one person to another, from one location to another, through the means of technology. Now, to understand it better, let's ask a few questions. Some common questions are, what is that information that we're transferring? That information consists of files, letters, applications, folders, or PDF documents that you have. Your images, the pictures you probably took when you were vacationing, you want to share it with your friends. Same thing with videos. You made some videos or certain videos that you see, you're transferring that. Music, instant messages. You use Facebook or WhatsApp or any kind of instant messages to share it with other people. Emails. So if you have personal email or corporate email account, you send emails to your boss or your coworkers. So you are sharing that information. Now, where are you sharing it to or with whom? As I said before, from person to person, from company to company, from location to location, which means any from one city to another city, from one country to another country. You share all that information through technology. When are you sharing? 24/7, 7 days a week, and 365 days a year. Yes, there is no business hour like a post office. You have to go in and you have to wait for the post office to open up so you could transfer your information. This is all happening in real time and at all times. Now, why are we sharing that information? That's a very good question. The reason we share that information, so you could have that information and you could make a decision, you could solve a problem, you could do some planning around it, and that could save you some time and make improvement to your system. And finally, you could save some money. So every company, every person, when they have some numbers, some information, they crunch, they massage those numbers, and so they could make a right decision based on the historical facts. Everything is about information. Now, we all know all these four things. Now, how are we sharing that information? That's where comes the technology. We need IT components to make that what, where, when, and why happen. And those IT components that you need to transfer information, those are like computers, operating systems, applications, and network security, database storage. You need all of these IT components and many more, by the way, to transfer information from one person to another. So, anyway, I hope now you understand completely that the real meaning of information technology. I'll see you in the next lecture. Hey, folks, let's take a look at the importance of learning information technology. It is, of course, very important for ones to learn the basics of IT in everyday life. So, if you want to buy a computer, or if you have a computer and you need to upgrade that computer, you need to know what's inside of it. What is a memory? What is a CPU? What is the processing speed? All that information you do need to buy a laptop in a smart way. Same thing if you wanted to buy a cell phone, you need to go out there, you need to know how much disk space it has, how much memory, CPU, the processing. For some people, the camera resolution matters. For some people, the applications, how fast it loads. For some people, how fast the internet is. There are many things. So all of those things that you see inside of your phone is actually a basic knowledge of information technology. Then moving on, every job requirement. Yes. So regardless if you are in IT or not, let's say if you are in a medical profession or you're a doctor, in a lot of doctor facilities or hospitals, there are these bigger scanning machines like MRI, the CT scans, and many other those radiology big machines that actually takes the scan of a human being and prints the report. You read the report, you need to understand how to operate those machines. Maybe there are some technicians that actually qualifies or have the major information or technical information on that machines. But you being an as a doctor, you need to know what's the really functionality of that machine, how it operates, very basic knowledge. Same thing if you're in accounting. In accounting, there are so many applications that people use. Those applications run on a computer. What happens if you are dealing with multi-million dollar balance sheets and suddenly your computer is running slow or crashes? You need to know some basic understanding of IT, right? Moving on, career path. Yes, that's one of the biggest one. If you are getting out of the college, you wanted to get into IT, then of course there is no such thing as basic knowledge of IT. You need to know everything inside out of an IT, and that's what this course is going to provide you everything that you should know about IT, even for the people who are actually into a different field and they want to switch to a different path. This is the best career path for them. Then, business startup. So, if you are starting a business for the first time, you do need to know your point of sale systems, what applications you need to run, how much resources you need. If you are putting up the HR applications, the accounting applications, if you are doing some kind of timesheet, you need all those applications. And of course, either you could do those applications outsource to another cloud company or you do it local. But again, all that cloud, local, hosting, all these keywords, you do need to understand. And the only way to understand those keywords if you have a better understanding of IT. All right, so the next one we have is the side hustle. Yes, so when you learn IT, you will also learn different ways to make money as well, because IT is the field that provides you a lot more opportunities as a part-time aside from having a full-time job. A lot of people are looking for freelancers, people who could help out short term, or people could work on a little different projects. You could find or you could provide your services through different websites that are out there. Some of the examples are like Upwork.com or Fiverr.com and many others, I'm sure. So When you are in the IT field or when you start learning IT and you refine your skills in IT on a specific field, you can earn as a passive income through these different websites that I mentioned. Okay, guys, so now we have a better understanding what is information technology. Now take a look at what a computer is. Of course, we need a computer for information technology to work. So let's take a basic definition of computer. A computer is a machine that can be instructed to carry out sequence of arithmetic or logical operation automatically via computer programming. Modern computers have the ability to follow a generalized set of operations called programs. These programs enable computers to perform an extremely wide range of tasks. Now, this definition I got it right out of the Wikipedia. Another definition of a computer is a computer is an electronic machine that manipulates information or data. So that information can be stored, retrieved, and processed the data. So you could save it, and anytime you need to pull that information, it can be retrieved from the disk. You could change that, process it, manipulate it, that information. That's when you need the computer. Now, let's take a look at my definition of a computer that will help you understand what a really computer is. For me, a computer is a device or electronic device that moves information from one person to another or from one location to another when a computer is connected through the network or through other computers. That's what really computer is. So another way or another definition would be a computer is used to run desired applications that are needed for personal and professional reasons. Now, ask yourself that the moment you turn on the computer, what do you expect out of that? Of course, it starts up, it starts the operating system that runs on a computer, and then what happens? You go to a certain application. You start Microsoft Word, Microsoft Excel, or you go to your games, or you go to the web browser, you start those applications, right? Without those applications, do you think you really need a computer? No. So the main purpose of a computer is to run those applications, and that those applications are the ones that makes life easier. Those application puts things on an autopilot for you. That's why we need a computer. Hey folks, we all know we speak different languages in the world, but what is the language for a computer? Now you coming into an IT, you should really know how computer reads your input from the keyboard, what language your computer speaks, and that is simple 0 and 1. So computer does not know any human language. So they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language, that 0 and 1 language, it's called binary. Computer store all characters as numbers on hard disk because computer don't know what is hello or how are you is. Computer converts that into these numbers, zeros and ones, and that's how it stores that into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power or if your battery runs out of your laptop, your computer will shut down, right? So computer to transmits the data to save that data, it actually uses 0 and 1, and that 0 and 1 concept came from the the electricity. 0 means off, and 1 means on. So this I or one that you probably see on your Switch. If you go to your Switch right now, or if you have an older Switch, probably newer Switch don't have those 0 and 1 anymore. But if you find one in your house, you're gonna look at it closely and you're gonna see one on top or at the bottom, depends which country you are in. So the one means that turn on. Zero means to turn it off. So we all know that how that switch works. So similarly, the computer sends or saves the data on the computer or transfer the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. That chart, each letter, that English letter that we have, has a number or a binary number associated with it. So like A has 100000001, B has 1000010, and so on. So now let's say if you type it in hello on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory that, hey, this hello means these digits, so process it. So the first thing it will do is will take the first character, which is H. And by looking at the chart, you will see the H translates to 1001000, meaning on, on, off. Same thing, E translate to 1000101. L, L, and O 1001111. So that's like a cheat sheet the computer has, and computer knows that when the letter H comes in or E comes in, I'm gonna have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off, on off, on off, on off, and that's how it actually translates or move the data from one computer to another or from your keyboard to the hard disk. Okay, moving forward, let's talk about ASCII. Now, you probably have heard of ASCII. What is ASCII? ASCII, first of all, stands for, or it is pronounced as ASCII, and it stands for American Standard Code for Information Interchange. It allocates a number to each letter, digit, and symbol. It is like a middleman or a translator between your keyboard characters and the binary. So every character that you see on your keyboard or US keyboard, that character has a number associated with it. That number was assigned by American Standard Code or ASCII people. So they were sitting there, they said, you know what? There's so many computers that we are building in back in 1960s, and they communicate with different ways. We need to come up with a standard, and they came up with the standard. And now they said we will assign that number to each character, and then that number will be translated into binary. So let's look at this chart. You will see the columns, the decimal, the binary, the octal, hex, and ASCII. So we'll cover the hex in a second. But if you look at the H, in the H value in the table has an ASCII code of 72. So the computer assigns 72, and then the 72 gets translated into the binary, which is again, that's what computer understands, 0 1 0 0 1 0 0 0. Okay, so as the computer it grew over time. It was introduced in many different countries, many different languages. So there were so many characters that were introduced. As you can imagine, there's so many languages in the world. So they were the first time the computer was introduced. Of course, that was in English language in ABC. So they didn't think of it that they would have to come up with different ways to translate. So they came up with more ways, and that is hex. So if you are typing in Chinese, a Chinese character could be a number that is assigned to it, just like American Association assigned a number in ASCII. So they take hex, convert hex to, again, to binary. All right, guys, that's a lot of information, but the main point that I want you to understand or take away from this lecture is that computer only understands binary, and those binaries are 0 and 1. Hey folks, in this section we are going to talk about the computer components. And the very first thing that comes in line when we are talking about computer components is the hardware. Now, what is a hardware? Before we get into the hardware, we need to find out where they got the name ware, W-A-R-E, and attach it with the hard. So where actually anything, any merchandise, any products or any goods is a ware. Now, in from Wikipedia, computer hardware includes physical parts of a computer, such as the case. Case is also referred to as chassis, where everything is combined together in a case. Then central processing unit, which is inside of the computer, monitor, mouse, keyboard, computer data storage, could be hard disk or external disk, graphic card, sound card, speakers, and motherboard. All of these computer devices that are listed here are actually the hardware. Now, my definition to make it a lot simpler when someone asks you what is a computer hardware, then I would say anything you can touch in a computer world is a hardware. Anything you cannot touch is a software or a firmware. That's a very simple and straightforward definition. So if someone is going to ask you what kind of computer you have or what kind of hardware you have, right away you have to say, I am using Dell hardware. I'm using HP hardware or Sony or whoever the manufacturer is. That's what they wanted to know, the manufacturer of the hardware that you have. Hey folks, in this video we are going to talk about software and operating system. Operating system is a software as well. And software is anything that you cannot touch, which runs inside of your computer, as compared to hardware is something you could feel or touch. Software is a written set of instructions that tell your computer what to do. Operating system, which is also a software, it runs on top of your hardware. Without the operating system, your hardware is just like a piece of brick or a piece of metal because it cannot function without an operating system. The operating system supports computer functions such as scheduling tasks, executing application, and controlling peripherals. So when you have the operating system, your operating system is actually controlling your devices. If you want to print something, through your application, let's say you have a Microsoft Word, you want to print your document, then that specific instruction goes to operating system and operating system sends it to the printer to print. Let's take a look at a few of the examples of our operating systems. Um, well, number one is Windows. Windows has the most market share in user environment. Then we have Mac. A lot of people use Mac as well. Then we have Linux. Linux is mostly used in the corporate world, and many times people use it as a command line. It also have a graphical user interface, which is called GUI, just like Windows. But again, most of the people use it without it, so it could function a lot faster. Another operating system you have Unix, which runs Solaris or AIX, and I'm sure there are many other operating systems that are out there. I don't want to list, but these are the main four operating systems that we could actually relate to. Then let's look at the example of mobile operating system that's running in your cell phone. Number one is iPhone, it runs iOS operating system. And the second one is Samsung, which runs Android operating system. Okay, so let's understand how our operating system works through this image. Here we have this image where the bottom layer you see, it's a hardware. On top of it, we have our operating system running. Then on top of the operating system, we have our application programs running. And who are using those applications? You. You are the users who are actually accessing that application. Now, to make it more simpler, let's put down our hardware, which is our computer. On top of our computer, we have our operating system, and we take an example of our Windows operating system. When you start up your computer, the operating system starts up, and then you might need to use an application. And in this example, we picked Microsoft Excel. You probably need to use Microsoft Word, or you maybe need to use Firefox browser, or maybe other applications. And now, who are using these applications? That is you. That's how the actual sequence of operation works. And the operating system, if you could see, it's sitting in the middle between the application and hardware, taking the instruction from you and the applications and handing it over to the hardware. Hello and welcome back. In this video, we are going to talk about the application. Right from the image, you'll see that's the third layer of the image where the application runs on top of the operating system, and users like us access those applications. So application is also one of the major components of computers. Application is a program or a combination of programs designed for users to perform certain or desired tasks. Take a look at the certain examples of applications so we'll have a better understanding. For example, Microsoft Word or Excel or PowerPoint or any of those Microsoft related applications are of huge examples of what applications are. Internet browser, if you're using Firefox, Google Chrome, or Microsoft Internet Explorer, those are all examples of application. If you're talking about the corporate world, in the corporate world, there are many bigger applications that manages your accounting or finances, and some of them like are ERP or SAP applications. For mobile users, like if you have a cell phone, you probably noticed that there are millions of applications that you could download from the Apple Store or Samsung Store. Those are those tiny ones that actually gets downloaded on your phone. It gets downloaded over your operating system, and those are called apps, short for applications. To further clarify the difference between the software and application, a software is anything that runs inside of a computer. So, a software can be an operating system because it is something that you cannot touch and it goes inside of your computer. A software can be an application that you create and with a combination of a program or multiple programs. So anything that is inside of your computer is a software, and a software is a very generic term that is used for all those coding programs that you create to run your computer. Hey folks, let's talk about the other IT components. We have already covered the three basic IT or computer components. Number one is the hardware. Second one is the operating system, also referred to as a software. And the third one is the applications. So now let's say if you have a hardware, your laptop or your desktop, and it has a Windows operating system installed on it. And then you need to use Microsoft Word, and that's the application. You could work on it, save your documents on that computer, works fine. Now, what if you wanted to perform different functions? For example, one of the things that you want to do is you write up the application or you open a Microsoft Word, you type up an application or letter, and you want to send to your friend. That friend is using a different computer. So definitely that's where the other components come in. And that component is the networking. So you do need a network between computers to talk to other computers. So in this lecture, we are going to cover the networking piece. So the very first thing we have to see here is your computer. Your computer has again hardware, software, which is the operating system, and the applications that you need to perform certain function. Now, what if you want to send or communicate to another user that is on a different computer? Now, let's see if that computer is within the same location, then you could simply use a crossover cable to connect one computer to another and you could communicate. Now, what if you have multiple computers within the same location? Then what you could do is you could put in a switch, a small switch with the port requirement that you have depending on the computers you have. So you could connect your computer to that little switch, or the Cat5 cable. Now, what is a Cat5 cable? That is something we will cover later on. And what is or how many little cables inside of a cat cable or cat6 cable, we'll cover that later. So anyway, for now, you'll see you will connect to that switch, and from that switch you see these multiple ports. Then you could attach those cables to these different computers, and that's how you could talk to these different computers. Now comes a question, what if there's a computer out on the internet, or it's somewhere in another location or another part of the world, and you want to talk to that computer? Then, of course, you need a modem or your ISP or your IP service provider. So in my location, I have a service provider like Cablevision or Optimum or Fios. So I'm sure whichever the part of the world you are, your internet provider is the provider who has provided you that modem that allows you to talk to outside world. So you connect your computer through the Cat5 cable again to that modem, and that modem is connected to the outside world, and that's how you communicate. But of course, if you need to communicate to the outside world, you need, or your computer needs, an IP address. IP address stands for Internet Protocol, and that is something we will cover in the later lectures. So that's pretty much another component of networking if you want two computers to talk to each other. I'll talk to you in the next lecture. Hey everyone, in this lecture we are going to talk about the database. Database is another component of IT or computers. So before we understand what database is, let's separate data from the base. So what is a data? Well, data is a collection of facts such as numbers, words, measurements, observations, or just description of things. For example, your name, age, height, weight, etc. are some data related to you. A picture, image, file, PDF, etc. can also be considered as data. So now, what is the base? Base is something like a system, a foundation, or a hub, or a central location where all the data come together. So now, let's look at the database definition. A database is an organized and systematic collection of data, generally stored and accessed electronically from a computer system. Databases make data management a lot easier. Now comes the question is, data can be stored in a spreadsheet or a text document as well. So why we need a database? Well, that's a good question. Like we use spreadsheets or we have a text document, we could put our name, our age, and all that information into those documents. So why do we really need the database compared to those regular flat files? Well, database store information more efficiently. Databases can handle volumes of information that would be unmanageable in a spreadsheet. Spreadsheets have record limitations, whereas databases do not. Compared to databases, spreadsheet can require a large amount of hard drive space for data storage, whereas in databases it takes a lot less space on your storage. Also, in database, joining records is a lot easier than compared to text or spreadsheet. So let's say if you have a spreadsheet that only tells you the age and let's say some information, date of birth of a user. In another spreadsheet, there is names and the address of that user. So sometimes when you wanted to get all that data in one line or in one record, so combining those two spreadsheets, it's a lot harder than compared to running some join SQL statements to combine that record. So that's why we have database. The pulling the database or data out of database is a lot easier than compared to these simple files. Hey folks, as we are going through the IT components, let's not forget the storage. Storage is an extended component of IT and it does play a very vital role when it comes to storing data. So let's take a look at what storage is. And I'm sure you guys all know storage is a place in your computer where data is saved. We know that when you shut down your computer, all that data is saved. And when you turn the computer back on, you could retrieve that data from the disk. So it can be simple hard drive or solid state drive inside of a computer, depending on what kind of computer or what kind of hard drive that you purchase. Now, storage can be internal or external. Now, internal, it's inside of a computer. Now, external, that's where this becomes an important factor or important component in IT is to have external storage or array of storage that we will discuss in a few minutes. Now, in IT world, storage is another extended component, which is a collection of multiple redundant disks, also referred to as disk library or disk array, that is used mostly in corporate world to store large volume of data. Yes, so let's take an example to clarify it or simplify it a lot easier way. So in your home environment, you have your desktop or your laptop. And your laptop, you all know we have a disk inside of that laptop. That disk we use, we create our data, we write our data, and then we save our data in that disk. Now, what happens if this disk dies or crashes or gets corrupted? Then, of course, you lose all your data from the disk. And I'm sure someone probably have experienced this kind of issue. I have actually experienced this issue too in the past, where I have saved all my data on that one disk and my computer crashed or disk crashed and I lost all the data. So, of course, that is something you could afford on the home. But when we are talking about the corporate environment, you do not afford to lose the data, the corporate level data. So, in corporate world, what they do is they actually buy these big shelves, big racks, and each rack they have multiple servers. They look like a server, but they have inside of these servers, they have actually arrays of disks. So each of that has disk, and many, many disks. And these disks are set up in a different RAID. What is a RAID? That is something we'll talk about later, definitely. But RAID in simple words is basically a redundancy of the disks. In case you lose one disk in this array, then you have other disk where you could get or retrieve your data. So this way, no matter what happens, or you lose one or two or three disks, or as many disks, depending on how you set it up, that corporate storage array, you will be able to retrieve that data. Now, that corporate storage can be accessed either through SAN or NAS. What are those terms? I will cover that in the later lecture. And I'm telling you, you do really need to know these things if you are getting into IT world. So, hope you understand what storage is on the corporate side, and we will cover much in detail in the later lecture. See you in the next lecture.
Hello, everyone. Let's take a look at virtualization. What is virtualization? Before we get into explaining the concept of virtualization, let's take a look and understand of how physical system configuration works. So, in a regular world, as you could see, there is a physical server. A physical server could be like a Dell or HP or any of those manufacturers that build a physical server. On that physical server, what do you do when you get that physical server? You actually install an operating system on top of it. And that operating system could be Windows, could be Linux, or any of the operating system of your choice, right? Then what happens? You install the operating system, and then on top of that operating system, you run your applications. Those applications are, for example, Excel, Word in Windows world, in Linux world, you'll run like a DNS application, NTP application. In a regular applications, where rarely enterprise level application like ERP, SAP, PeopleSoft, all of those applications run on those on that platform operating system is. So this is how you see an ideal or in a regular world how the layout works. Now, what's the problem with this? The problem with this is you have a physical server. The physical server has 16 gig of RAM and 4 CPU. And then you install operating system on top of it. Operating system only needs 4 gig of RAM and 2 CPU to run. And then you install an application on top of it, and that application only needed 2 gig of RAM and 1 CPU for that application. What happens then?
Then you have 10 gig of RAM and one CPU that are wasted. Yes, resources are underutilized.
That's why the virtualization was born. People thought, they sat down, they said, you know what? We have this physical server with so much resources. We only run one operating system and one application, and everything else is wasted. We gotta come up with a better solution. So now let's look at the virtualization. When virtualization came into being, then what happened? What happened was there's a physical server, same way, running Dell on HP, whichever whoever the manufacturer is. Then you install a virtualization layer on top of it. A virtualization layer from anywhere, like from VMware, from Oracle Virtualization. Then you install operating systems on it. So you could install 2, 3, 4, how many operating system you can, depending on the resources that you have on the physical system. And then on top of those operating systems, you have the application individually run on each of that operating system. Now, what's the advantage? Let's look at the advantage. That's a physical server. Again, going back to 16 gig of memory and 4 CPU, you install a virtualization layer which takes up all your CPU memory and CPU. Perfect. Then that operating systems you have, then applications, each of that operating system application has 4 gig and 1 CPU. So each of that operating system has given all those resources. What happens then? All resources are fully utilized, not wasted. See how we could take the full advantage of all those resources? So again, one more thing. Remember those days when you have one physical server and one operating system, and then people came up with another idea of, you know what, split the disk in half and let's do dual boot. So one of the partition would run, let's say Linux, and one partition would run Windows. But the problem was with that is you could run only one operating system at a time. In virtualization, this is the beauty of the virtualization. You don't have to have one operating system run at one given time. You could run both or 3 or 4 operating systems at all times, all at the same time. That's why the virtualization is so important and so beneficial. Again, in layman's term, virtualization is really not real, but it is actually real. It is utilizing the system resources and sharing those system resources among all the operating system that runs on that physical server.
Hello, everyone. In this lecture, we are going to talk about cloud. I'm sure you have heard this word cloud or IT cloud, cloud storage, cloud computing, cloud networking so many times, but maybe you're having a hard time understanding what really cloud means and what kind of services we could get from the cloud. In this lecture, I am going to make sure that I explain it to you, the cloud and its purpose and features in a very simple language. That is why recently cloud has become also an extended component of IT because a lot of companies are moving to cloud and therefore you need to understand the concept behind the cloud. All right, let's look at the definition of cloud first. Cloud computing is the on demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. Now, pay attention, without direct active management by the user. The term is generally used to describe data centers available to many users over the internet. Like there are data centers somewhere, but those data centers are available to you through the internet. Now, for those people who do not know what a data center is, a data center is where all the companies have their IT resources set up like in a shelf, all the computers are there, all their hardware gear, all their networking gear, actually at a dedicated place. And that place is called data center. Now, let's go into details of defining how we could differentiate cloud from a regular data center. So, in our regular data center, for example, you work for a company ABC and you work for the IT department, and they have their data center. In their data center, of course, you have servers, and those server, the hardwares are actually managed by maybe the data center technicians or hardware technicians. Then on top of those servers, we have the operating systems running. Those operating systems are managed by system administrators in your company. And then there are applications running on that operating system like SAP, Oracle, or many other applications, depending on the requirement of your business. Of course, for those applications, you need the users who manage those applications. Then also in the same data centers, you have networking gear like firewalls or routers and switches. Now, if you most likely you do have them in your data centers. And then what do you need? You need people like network administrators or security administrators to manage those network devices or configure them for servers to communicate. Also, if you are running an application, I'm sure you want to put them on a storage that is redundant. So you need external storage attached to your server. And when you have the storage, what do you need? You need people like storage administrators to manage those storage arrays. Now, you see, you have to hire so many people in your IT department to actually get the application working for you. Now comes the cloud. The cloud companies came up with this concept of cloud. In the cloud, they have just the same data center like you have for your company. But you don't know where that data center is. Maybe it's somewhere in the world that you don't know, and you really don't need to know where that is. All you need the access. In that cloud technology companies who actually provide these cloud technologies, they already have in-house people, the administrators like storage, network, system administrators who actually manage the servers, the operating system, the network, the storage, and everything. They do everything for you. All you have to do is manage your application. You will access your application from those servers, and you will only need those users to manage those applications. That is the main difference, and in very simple words, the difference between the actual physical data centers that you have been working on with your company and anything on the cloud. And some of the examples I'll give you cloud is Azure Cloud, VMware Cloud, Amazon Cloud, one of the biggest one. We'll talk about clouds in a later lectures also. I will go through the difference between what are the difference between private cloud, public cloud, and some of the more details in the later lectures. But for now, I am sure you got a good gist of what a cloud is. And if someone is asking you to explain cloud, I'm sure you could give them the same example to explain what a cloud is. Hey folks, in this lecture, we are going to talk about IT security. Security is another extended component of IT. When we are talking about all these different components, please make sure we are not overlooking the security, which is also one of the most important aspect in IT. Let's take a look at the IT security definition. Security can be referred to as computer security, cybersecurity, or IT technology. Security is the protection of computer systems and network from information disclosure, theft of or damage to their hardware, software, electronic data, as well as from the disruption or misdirection of the services they provide. So basically, the security to secure your network or your environment, not only to protect your data, but also to protect your hardware where your data resides, the software that controls that data, and any of the services that runs on top of those software. All right, IT security prevents malicious threats and potential security breaches that can have a huge impact on your organization. When you enter your internal company network, IT security helps ensure only authorized users can access and make changes to sensitive information that resides there. IT security works to ensure the confidentiality of your organization's data. So security can be applied at the following levels. It can be applied at the hardware, operating system, application, network, storage, database, and virtualization or cloud level. You do need security on all of these components, and security wraps around all these components. In the later lectures, when we get to the broader topics on the security, I will cover what are the security threats, how the security can be breached, what kind of security breach there are, and how are different ways to protect our computers. So stay tuned. I'll see you in the next lecture.